Okay, in this video, I'm going to go over part 1. I'm going to erase this here. Part 1 of 12.1. And this is going to go over the basics of sine, cosine, and tangents, SOHCAHTOA, and how to solve for missing side in a triangle using sine, cosine, or tangent. The second video will go over inverse trigonometry. And so again, this is part 1. Introduction to trigonometry. So trigonometry is the study of relationships between sides of a triangle. Sine is a ratio of the length of the opposite side, opposite leg, to the length of the hypotenuse. Cosine is the ratio of the length of the adjacent leg to the length of the hypotenuse, and tangent is the ratio of the length of the opposite leg to the length of the, that's a typo there, adjacent leg. So notice we have words like opposite and adjacent and hypotenuse. Opposite and adjacent refer to legs, and that sine, cosine, and tangent are all ratios of each other. So I'm going to get into an example here. Let's say I have a 30, 60, 90 triangle here. And sine, cosine, and tangent only work on right triangles. So let's say this is 60 degrees, 30 degrees. And if this is 5, the short leg is 5, what's the hypotenuse going to be? Well, the ratio, if you recall, of the 30, 60, 90 is 1 root 3 and 2. So that's 60 degrees. That's 30 degrees. Okay, so 1 root 3 and 2. So if this is 5, that's going to make this 10. 5 times 2 is 10. And the long leg is going to be 5 root 3. Okay. Now, if I get out, I'm going to get out this calculator here and use it. When calculating sine, cosine, and tangent, you're going to use your calculator. But before you do, go to mode. Hold on. Do I need to restart this? I can turn it. Oh, turn it on. Okay. Go to mode and make sure that yours is set to degree, not radian. And then exit out of there. Now, if I go sine 30 degrees, I am going to get 0.5. And that tells me that I am in degree mode. So sine of 30 equals 0.5. Now, sine is the ratio of two sides of this triangle. So we found that sine of 30 degrees equals 0.5. And I'm going to go ahead and call these A, B, and C. Those are the vertices of this triangle. So if sine 30 is 0.5, the question is, sine is the ratio of what two sides of this right triangle? Well, 0.5 is equal to 5 over 10. So basically, it's the ratio of this side over this side. We're going to give all these sides names. The side opposite the right angle is always called the hypotenuse. Okay. Now, the other two sides are both legs. So the question is, how do we differentiate between each leg? Well, in this triangle, I've been saying, the shortest leg and longest leg. And that works, but we want names that will work for any size or shape triangle. So let's do, let's use the word opposite, because this side is opposite that angle right there. So this is going to be the opposite leg. And that means that sine of 30 degrees is equal to the opposite leg divided by the hypotenuse. So sine is opposite leg over hypotenuse. And if you go in your calculator, and I'll go ahead and get this out. I'm going to put this on the next screen here. Okay. You go on your calculator and type in cosine of 30 degrees. You'll get 0.866. So cosine of 30 degrees equals 0.866. And when you take these sides and divide them, you'll find that's the same as 5 root 3 over 10. So cosine of 30 is equal to a ratio, well, 10 is the hypotenuse. We know that. But what about 5 root 3? Well, that's a leg of a triangle, and we're going to call that the adjacent leg. Adjacent leg. And the adjacent leg is the leg that is next to, touches the angle you're talking about, right? So that's this leg right here. And that leg touches angle A, that 30-degree angle. So the name adjacent is related to what angle you're talking about. You can do sine, cosine, and tangent with respect to the 60-degree angle, and then the word opposite and adjacent are going to flip. They're going to switch, but the hypotenuse will remain the same. The last ratio that we have is tangent. So tan of 30 degrees. And when we calculate that, we will get, oh, looks like this switched out here. Let's go ahead and do that. So when we do that, we will get tan, oh, hold on. What happened here? Tan of 30, and that gives us 0.577. So 0.577. And that ends up equaling 5 over 5 root 3. And that's the opposite leg divided by the adjacent leg. Okay. So this is going to take some time to process. I remember when I first learned this in high school, I memorized it. It took me doing it again in physics, and then later in college in my physics and engineering classes, and finally, I think the 5th or 6th time, you finally understand what this is. And so I'm really going to push for understanding of this. It's really easy because you plug sine 30 into your calculator, you get 0.5, and so you think, well, sine is just decimal number. But sine's a ratio of two sides of a triangle. When you understand that, you're going to be able to use this to solve problems when you're doing physics and other applications a lot easier. So we'll get to that here. Okay. So let's go back to the formal notes here. So here's an example of a triangle, and you notice how opposite and adjacent are labeled. Okay, so if I look at sine A is going to be opposite divided by hypotenuse. Cosine of A, and then we'll do tan of A. All three of these. Okay. So looking at this triangle, you see how the Sides are labeled opposite, adjacent, hypotenuse in red, green, and blue, and then the sides are labeled A, B, and H. So sine of A is equal to opposite, which is A, over hypotenuse, that is H. Now what does cosine A equal? Adjacent leg over hypotenuse. Adjacent leg over hypotenuse. What letter represents the adjacent leg? Well, it's going to be B, and the hypotenuse is still H. Tan of A is going to be the opposite leg divided by the adjacent leg. And opposite leg is going to be A, and the adjacent leg is B. So to review, sine, cosine, and tangent are all ratios of two sides of a right triangle. This only works for right triangles. And they are, the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. Okay, well that's great, but what if we do this with respect to the other angle? I'll go ahead and erase that here so we have more room to write. Okay. What if we do this with respect to angle B now? So we have sine of angle B, cosine of angle B, tan of angle B. Now, the ratio is still going to be the opposite leg divided by the hypotenuse. Well, the hypotenuse is H. We know that. That's not going to change. But what's the opposite leg? Is it A or B? The word opposite and adjacent refer to locations of the legs with respect to the angle you're referring to. So if you're referring to sine of A, the side opposite it is A. And the adjacent is B. Hypotenuse is H. If you're referring to angle B, the side opposite angle B is side B. So that's the side opposite angle B. The adjacent leg is the one that touches it. Now the hypotenuse touches it too, but the hypotenuse is not a leg. So the adjacent leg is A, hypotenuse is H. Tan of B is the opposite leg. In this case, that's B over the adjacent leg, which is A. So you can see how the ratios have switched. Sine A is now the same as cosine B. Cosine A is the same as sine B. And tan A and tan B are just reciprocals of each other. Okay, let's do another example here. Let's say we have a 30, 60, 90 triangle again. Now that's going to make this 6 root 3. And this is 4 root 3. And this is 12. And this is 8. I'm going to call this A, call this D. Okay. So sine of A, this case is sine of 30 degrees. That is equal to the opposite leg over the hypotenuse. Well, the hypotenuse is clearly 12. Which leg is opposite, 6 or 6 root 3? Well, that would be 6, which is equal to 0.5. And if you put sine 30 into your calculator, assuming you're in degree mode, you will get 0.5. Okay, let's try cosine. Cosine of A, that's cosine of 30 degrees. It's equal to the adjacent leg divided by the hypotenuse, which is 12, and this time the adjacent leg is 6 root 3. When you put it in your calculator, you get 0.866. And putting in cosine 30 will get you 0.866. Again, what is cosine? What are sine? They are ratios. So even though you get decimal numbers that aren't written as fractions, they're still ratios of sides of a right triangle, where one of the angles is 30 degrees. Now, tan of A is equal to tan of 30 degrees, which is equal to opposite leg over adjacent leg, which is equal to 0.577. Now, it's standard in these problems to put the decimal points out to at least 3, if not 4 decimal places when making calculations. So get in the habit of that. Okay, what about the other triangle? Well, let's start with sine here. Sine of D is equal to sine of 30 degrees. And in this case, you're going to get opposite leg over hypotenuse, which again is 0.5. It's exactly the same ratio. Even though the triangle is a different size, they are similar triangles, and so the corresponding sides are proportional. So 6 over 12 equals 4 over 8. And if we keep going, cosine of D equals cosine of 30 degrees, which is equal to adjacent leg over hypotenuse. All right. And that is equal to 0.866 again. So notice how even though the triangle is a different size, it's still the same ratio. It's 0.866. So when we do tan of D, that's tan of 30 degrees. That's going to be the opposite leg divided by the adjacent leg. That will again get 0.577. Okay. So what if we do it with the other angle? Let's say this is angle B and this is angle E. Hi.